Good afternoon, engineers. This third lecture of MATLAB will be dealing with how to write functions in MATLAB. Suppose we have a main program and there is a function. Instead of putting all the software in the same main function, we can put all those in a separate file, .m file, call it as a function. From the main routine, we can call the functions. Instead of writing in the same file, we can keep it in separate file. This makes the program readable. Another advantage of writing a function is, suppose we have a main program, main code. It's, this calls a function, say function x. In function x, we can put it function x dot m. We can put it in a separate file. Certain code we can write. From the main program, we can call function x. Advantage is, suppose we later we want some improvement. Instead of function x, we can write a separate program without changing the main code. We can call, instead of function x, function x1 in main file. We can, instead of that, we can call function x1. We can comment it or we can remove this function x. So function x1 will be executed, which will be altogether a different code. We need not change the main code. Otherwise, everything will be written here. We have to comment it or remove it. This is a unnecessary headache. So, whichever we want to change many times, some improvement in the development phase, we can put everything in a separate file called function. So, from the main code, we can call this function. So, once it calls, it, the function should end with a .m file. Function x will be executed. Once it is executed, it will return back to the main code. It will follow the next line. After function x, this line will be executed. This line will be executed. We want to change different function. We can write, instead of function x, we can call a function x1. We can put it in different file. We can, instead of calling a function x, we can call function x1. There is an important difference between C and MATLAB. A function takes certain input parameters. Function x has some certain input parameters separated by comma. A, B, C, etc. Some input parameter, it could be a variable. Certain variables we feed to the function to be executed. The function returns certain variables. It may or may not return, but if it returns, say D, E, F, the main difference, the input parameters we put by this kind of brackets, whereas output parameters we write by square bracket. We distinguish by using square brackets and comma. So main difference between C and MATLAB is, MATLAB, like C, it can accept multiple input parameter. Multiple. Here there are three input parameters. MATLAB also can output multiple output parameters. Here there are three output parameters, whereas C can output only one parameter. MATLAB can output more than one parameter. So this makes our job easy. We can give as many variables as we want to output for the function to output. Another thing is, these parameters are local variables. Whether it is input or output, they are local variables. The function calling Suppose you input A, B, C in the calling main routine. The function x can accept, say, function x. This is the function x. Function x. This can have in local three variables: input one, input two, and input three. These are local variables. They don't have. They are not same. Here, the calling program ABC in the function input one, input two, input three. So they are local. Like that, the function returns local variable. So DEF in the main routine, DEF will contain the returned variables. Here we can have some W or M and W. M and O, say M and O equal to function X. These are this function X will be function X dot M file. We can put it in a separate file. We pass the input parameters, output parameters, the function will process and output. Important thing is the input and output parameters are local variables. The distinction between C and MATLAB, unlike C, MATLAB can return multiple parameters. Certain tasks we execute, we write a function x dot m. We are not happy, we change to another name, function x1. It is a modification or improvement, say. So instead of function x, we can call function x1 in the main routine. Only one change. We need not change all the lines of function x1. Function x, we need not change all the lines. Instead of that, we need not replace by function x1 lines. If you don't use function, in the main line, if you use all the lines of function x, if you want to replace, we have to write all the lines of function x1. We have to replace. That is a tedious task. So this is the advantage of writing a function. The function should be in a separate file and it should end with a dot .m. I will give an example of function. There is a main routine. It has input array. Input array equal to 1 colon 10. 1 colon 10 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 10. Up to 10. The function returns calculated mean. Then calculated standard deviation. The function is stat. Stat stands for statistics. Stat input array. So this is the main routine. This is the main routine. We write a function in a separate file stat.m. Stat.m. This is a separate file. In this, we are calculating the mean and standard deviation. The function returns mean and standard deviation, STD, standard deviation, equal to stat input. N equal to, in this function we write n equal to length of input. So input is an array. Suppose it has some, it can have any length. It could be 5, 6, or 10, or 20. It could be anything. We read that length command read the length of the number of elements in the vector. So it reads in n. Then mean equal to sum input divided by n. Standard deviation equal to standard deviation equal to square root of sum input minus mean dot exponentiation by 2. So input is a vector. We subtract the mean, so it should be a vector. So this dot rise to power 2 will, the difference between input and mean will be squared. It is a vector. It is squared because of this dot conversion. It raises individual elements of the vector. First element square, second element square, third element square, fourth element square, etc. N elements square. Each element is input minus mean. That's it is squared. And the sum command, whatever this each element is squared, that it will add all. It will sum them. Then we find the square root divided by n. This is standard deviation, right? So standard deviation is calculated, mean is calculated. So this function returns mean and standard deviation. Input is a single array, output is two variables, two scalar variables. The function accepts this in calculated mean and calculated standard deviation. This is a typical function. How to write a typical function? This stat.m is a separate file. No, please note, this function outputs two variables. Unlike C, it can have output more than one variable. It can also accept more than one input variable. It can also output more than one output variable. Then we go to control statement. We are initializing a variable x equal to 2. If this is like C only, if else is similar to C, if x equal to 2, z equal to 5, else if x equal to 3, z equal to 7, else z equal to 10. And here we initialize x equal to 2. So first condition whether it is met, it will check x equal to 2. Yes, it is meeting. So z will be initialized to 5. Suppose if we, instead of that, if we initialize x equal to 3, then first condition will not be met. So second condition will be met, x equal to 3, z will become 7. we do not initialize x equal to 2 or x equal to 3. Say x equal to 9. Both conditions are not met. X equal to 2 not met because x is 9. X equal to 3 not met because x equal to 9. So both are not met. Else here we don't check the condition. Z equal to, if these two are not met, automatically this will be taken care. Z equal to 10. 10, if you print 10, see, 10 will be output. The routine will output, the software will output Z equal to 10. It will display 10. This is a simple if statement. It is similar to C. For the sake of completeness, I am explaining this. Then we discuss about switch statement. Switch case. Let us initialize x equal to 10. We are writing x equal to 10, not equal to x equal to 10. Switch x, case 10, z equal to 9. Case 5, z equal to 8. Case 3, z equal to 9. End. So here we initialize x equal to 10. Switch x. Case 10 it will match. So z equal to 9 will, z if you type 9 will be returned. The function will display z equal to 9. Instead of that x equal to 5, if you give, this will not be met, this will be met, z equal to 8 will be displayed. Instead of that, case 3, z equal to 9, if you initialize, instead of x equal to 10, x equal to 3, if x equal to 3, if you initialize, instead of x equal to 10, if you initialize 3, this will not be executed, this will not be executed, case 3 will be executed, z will be displayed as 9. Sorry, let us say 90. It is, I have given same. So 90 will be displayed. 90 will be displayed. I made it wrong. So it is this switch statement is similar to C. There is no difference. I am giving this for the sake of completeness. I don't want to explain in detail because everybody knows C. Next is for loop. Let us initialize the variable h. H is a vector. H equal to 2 colon 2 colon 20. That means 2 increment is 2 here. Starting is 2. It is just a coincidence. We can have starting 5 also or 1 also. No problem. You can have any start value. You can give negative value also. From 2 it starts incremented by 2. 2, 4, 6, 8, 10, 12, 14, 16, 18 till 20 it will go. Hatch will be 2 to 20. It will initialize the input vector h. X equal to 1 to 10. Increment is 1. If you don't give that middle, after colon this middle value, then increment is default is 1. 1, it starts 1, 2, 3, 4, 5, 6 up to 10. So h has 10 values. It is a vector of 10 length. X is a vector of length 10. Then we are using a for loop for k equal to 1 to 10, sum equal to sum plus h of k multiplied by x of k. Here we forgot to initialize sum equal to 0 because we are using already sum. Without sum equal to 0, it will give an error. Sum equal to 0. This is a for loop. K equal to 1 to 10. End. We display sum. What will happen? Sum is 0. First it starts with 0. 0 plus h of 1. H of 1 is 2. X of 1 is 1. So 2 into 1, 2. So 0 plus 2, 2. Then next time this 2 will be RHS 2 will be there. LHS will be calculated. H of 2. K will be incremented. It will become 2. H of 2 is 4. So first time 0 plus 2 into 1. Next time 2 plus 4 into 2. That is 10. Like that, it will go 10 times. Finally, that sum will be, cumulative sum will be in sum. It is a single scalar variable. Sum is a single scalar variable. So for loop is also similar to C. Next is while loop. We initialize a variable n equal to 5. We are finding a factorial. We are writing a program for finding the factorial of n. N factorial we want to find. In this particular example, n equal to 5. 5 factorial we want to find. So factorial we initialize to 1. Factorial equal to 1. While n greater than 1. Factorial equal to factorial into n. N equal to n minus 1. End. N equal to n minus 1. So what will happen? It will start with 5. We are initializing factorial equal to 1. So 1 into 5. Factorial will be 5 first time. N will be decremented by 1. It will become 4. So till becomes 0. So n will become 4. It will go again. N greater than 1. Yes. So it will be multiplied by 5 will be multiplied by factorial was earlier 5. 5 will be multiplied by 4. Like that it will go. When n equal to 1, it won't execute. It will come out. So we are finding the factorial of n. So this is same as C. Just it is a while loop. For loop we saw, while loop we saw. Certain next we will have certain commands in MATLAB which are very much useful. Unlike C, MATLAB is very easy to deal. One is it has a complex input, real and imaginary. In MATLAB, you have to write routine. This is one thing. Second is if you want to load some variable from a file or save certain variables into a file, That is easy. Unlike we don't have to have F printer, F scanf, that kind of difficult software for that. MATLAB has built-in libraries for that. For example, we will see save command. Save command. There is a file called .mat file in MATLAB. .mat. Variables can be saved in .mat file. .mat, M-A-T, .mat file. For example, x equal to sine 2 into pi into 100 divided by 1000 multiplied by, it is a vector 0 to 999. Sorry, 1199. 1999. So what is this doing actually? So it is producing a sinusoidal tone, Q tone. This is sampling frequency called, we will talk about these things later in DSP class. Sampling frequency. This is the analog signal frequency. So there is a sine wave of 100 hertz. This 100 hertz sine wave. We sample it. We take samples. We take many samples like this. We take many samples at 1000 hertz. This 100 hertz sinusoidal wave. We take samples at 1000 hertz. Then the sampled value we put it in array X. X is an array of length 0 to 1999 means 2000 length, because 0 1 we have to add. So 2000 length array. Sinusoidal tone is sampled and saved into the array. You write a program for this. Then you, in your routine, you are initializing x. Then y equal to 1 to 2000. 1 colon 2000. What is 1 colon 2000 means? 1, 2, 3, 4, etc. up to 2000. Length is 2000. It is a vector of 2000 length. So output is out. Out equal to sum x dot star y. Dot star, as I already told, dot star means element. So x1 multiplied by y1, the sums all. Then x2 multiplied by, it will multiply element by element, etc. x 1199, sorry, x0, because we start with, sorry, x1, because MATLAB always starts with 1. It doesn't start 0. Unlike other languages, MATLAB, any vector, the index will start with 1. So 0 to 1900 means 2000, x 2000 into y 2000. So this you have to be careful. MATLAB will never accept the index either 0 or negative numbers. It will always have positive number. It cannot have 0 or negative number. So it will 1 to 2000. The vector length will be 1 to 2000. X 2000 into Y 2000. So this is the length of element by element we have multiplied. We have a 2000 length vector. This sum commands sums all these 2000, 1 to 2000 length. It will sum all and it will save it in out. It is a scalar. So we want the output to be saved in a file. We can give save. After this is executed, out will display the value of this sum of x dot star y. Sum of x dot star y will be displayed. If you give type out without semicolon, it will be display. Now I want to save it in a dot mat file. Dot mat file. Dot mat file I want to save. Dot mat file. Save. I give out. Sorry, I give this is wrong. Save. I give a file name. Save result. Result dot mat. Result dot mat. Result dot mat. I save this out variable. Comma out. Result dot mat. We put it in single quote. Out is the variable. If you give a semicolon, the out variable will be saved into a file called result.mat. In this example, we have only one variable out. We can have multiple variable out, out one, out two, etc. Say out one, out two. If we have three variables, suppose we can save all. If we save simply without specifying save dot mat, without out, all the out one, out two, all the three, everything, whatever variable, all the variables will be saved in result dot mat. But if you want certain variables, we can specify the variable name, not all. If you don't specify the variable name, all the variables which are displayed or in that code, it will be saved in the .mat file. Suppose we have saved in .mat file the variable out. We want this. We have saved in .mat file. Result .mat. Suppose we want to see that variable. We load the file variable letter. Load result .mat. Load. That not we are loading the file. We don't need input by fscanf all those headaches. It is very simple. Load result .mat. If you type this, if you see the variable, out will be displayed. Out will be displayed. Whatever suppose I'm giving, I didn't calculate. Out is say 500. 500 will be displayed. If you type out, 500 will be displayed. So we can save all the variables into a file. We can load the variable from the file. Typical use of this saving and loading. Suppose we design a filter using filter design package. We design a filter, some low pass filter. Low pass, the coefficient of low pass is low pass coef. This is the coefficient. All the coefficients are in this. It is a vector. Say it is a 100 length vector, 100 by 1 vector. We can save this in a file called save filter coef dot mat. We can simply type semicolon. So all the low pass filter coefficients will be saved in filter coef dot mat. We can save it. We can design the filter separately and keep it in filter.mat folder, filter.mat file. Later, if you want to use this filter, if you want to filter some signal using this filter, so we can load this filter. Load filter coif dot mat. Then if you type this and semicolon and enter, you can see the variable low pass underscore coif. It is a 100 by 100 by 1 vector. It will display. So with this coefficient we can use it to filter a signal. We can use this 100 by 1 coefficient, right? We can use it. So we can keep all the filter coefficient different dot mat file, and we can load in the main code. We can load the mat file. Then you use the variable. We need not in the main routine. We need not design the filter. Designing the filter, we can separately do it and save the coefficient in dot mat file. This is the use of load and save commands. With this, we will conclude this class. Next few commands only we will see, and then we will finish MATLAB important important commands. As I said, toolboxes we will see later while dealing DSP subject.